Hello ladies and gentlemen, we got one more video today over probability. We're going to talk about experimental probability. This is really the same concept as theoretical probability, which we've already done. Okay, when we're talking about the number of positive outcomes compared to the number of total outcomes, but we're going to use actual trials and data. That's really the only difference. So for example, we have a bar graph here, and it shows how old adults in a survey would choose to be if they could choose any age. So find the experimental probability. That means use the actual data and graphs here to find the probability that a randomly selected adult would prefer to be at least 40 years old. So the first thing that we got to figure out then, if we're going to find the total number of possible outcomes, okay, here's our fraction, okay, is at least 40 over the total. We need to find the total number of possibilities first, right? So what we're going to do then is we're just going to simply look, here's the number of results of each kind. Let's add them all up and find out how many people they surveyed. And that's going to give us our total. So here's what I got. Let's see, can you see the calculator? Yep. 463 plus 1085 plus 879 plus 551 plus 300 plus 238. I add all those up. They must have surveyed 3,516 people. Now, how many of those people said that they want to be at least 40 years old? So what I'm doing is I'm looking at the right-hand side of this graph, right? They said they wanted to be at least 40, but so did they, and so did they. So I'm going to add 551 to 300 to 238. That tells me that 1,089 out of the people said at least 40 years old, right? So my fraction is 1089 out of 3516. Pretty simple problem, right? I'm going to do math fraction, and it tells me that that reduces to 363 out of 1172. There's one way to state it. Or you can see up above that I could state that as, or a 0.3097. So if I'm going to round that, it looks like it's going to be 0.310. I could state it as a decimal. Or I could say 31% chance, 31.0% chance that the person that I randomly ask is going to say that they prefer to be at least 40 years old. So experimental probability, pretty simple. It's a matter of looking at a graph or a table, which is a pretty important skill, and finding the total number of possibilities, so the number of surveyed people in this case, add all those numbers up, and then on the top of the fraction is how many people meet my criteria. In this case, at least 40 were only the numbers on the right-hand side, right? Adding them up. All right, so I think you're going to be good with experimental probability. I think you're going to be good with the odds even, and I think you're going to be good with the six-sided die stuff. As we go to the homework, just remember, video 2, the permutations and combinations, those will be the tough ones. We're going to spend a lot of time there. Please ask for help when you need it because these problems get pretty confusing.